Hello, everyone. Welcome to our ZK Cloud Infrastructure User Group online meetup. This is our first online meetup after the lockdown, and we'll be carrying out online meetups probably at least by the end of the year. But you can find all the updates and everything on our page. We'll try to escalate the new meetups upcoming as soon as possible. But today we're going to start with Azure Virtual WAN, and our guest is Dhawal Thaker. So he has already presented some interesting concepts earlier in our meetups, and I would like to welcome Dhawal to our first presenter as being an online first presenter on UK Cloud user group, and thank you for being here. So Dhawal is about to start the presentation. I would like everyone to enjoy, and if you do have any questions, please leave it in a comment section. If you have the chance, we are hosting on a Teams first time, so we are not sure how good or how bad the experience is for the outsiders. So we'll try to record it. If you don't have the option how to make a questions, feel free to drop the message within the meetup space. So me and Daniel are keeping an eye on it, so we'll be able to translate. So Dhawal, thank you very much for being our host, first host presenter. Super excited to have you here. And just before you start, I would like everyone to encourage to buy a coffee for our presenters, which you can find on the Meetup page, so that while we preparing all the information, presentation, and demo to share during the nights, that it would keep them at least awake. So thank you very much, Dhawal, and yeah, please.
Thanks a lot, Marty. It's been a while, right? And lockdown, and I would have loved to meet people. It's very interesting to be on a meetup where you can actually can't see people. You're just talking, and
Exactly.
it's been like that. It's been like that for the last 5 months, hasn't it been? So you can't. So generally, you feed off the audience, right? It's like live stand-up comedy. All right. So let me just start with Azure Virtual WAN, and like our meetup, this is also something that's pretty new. We're meeting for the first time online, and this is something that came in on the back of virtual, a very huge demand from the consumer base. The reason behind that is historic. So like last time when I was speaking, I always like to go into the history as to why certain things were done and why certain things are the way they are. Because unless and until you learn from your mistakes, you won't actually reach a better place. So what we're trying to do over here is I'll just start with the index. Okay, that's the first hiccup. I'm not able to change the slides. Hopefully the slide changed, Marty, at your end.
Yes, it did change. So we do have index, the first slide of the index.
Oh, fabulous. So what we're going to start with is first look at what were the different networking options prior to Azure Virtual WAN, and then we get into Azure Virtual WAN, and then understand what are the components, and eventually understand what kind of use cases it solves, what are its benefits, and why it's become more or less a lucrative option for the consumers to go for. So like last time, we go into a historic slide. So when cloud started, and when I started with cloud, can't believe it's been 9 years. Interestingly, Azure did not have compute capability. So it started with something which is good old and known as cloud service. What it was is a web hosted app hosting platform where you could actually directly deploy .NET based solutions. The only way that it could communicate back onto on-premise was via service bus, which was nothing but a WCF, which is rehosted and exposed over internet. So what it used to do is it used to allow those API communication, and that was the only way to communicate back into on-premise networks. Now this was way back in 2009, 2011 kind of zone when it was just starting. So a lot of the enterprises were just beginning on their cloud journey and were looking at options as such. And the first applications that went, I remember the first application that I migrated on Azure was a time entry system for one of the customers, which is more or less a giant in retail industry, but it was their time entry system that we took first onto Azure. And it was a painful process. It took us 7 months to take one application, and now when we basically go ahead and do migrations, it's generally between half an hour to 2 hours to migrate one application. So that's how it's been kind of sped up. Once that was done, we had virtual networks coming in and virtual machine coming in. And that was the early phase where enterprises were coming in and taking advantage of cloud. This was the phase between 2011 to the time that ExpressRoute circuits came in. And what it allowed to do was you had site-to-site connectivity using IPsec tunnels. Now, these tunnels are very slow. And I remember this phase as well because I was doing SharePoint migrations at that point of time. And I remember because there was no way to ship or no way to put data over internet into the cloud networks. So we used to have those good old briefcases, more or less like the James Bond movies, with all the hard disks, which we used to kind of ship to Microsoft, and then Microsoft used to load that data, and then that data was available. So imagine we had to migrate a 64 terabyte database. So we had to it used to take around 2.5 months. So first somebody had to go into the client's data center, get the data onto a disk, then make it secure using some kind of encryption mechanism, BitLocker or anything, and then ship it over to Microsoft's data center in Amsterdam, and then they used to load it, and then we used to get that. Now this was becoming a bit of an issue, plus the overall connectivity latency. So to connect something on Azure or on the cloud was taking a heck lot of time. So then came the revolutionary solution of ExpressRoute circuits. Now, what it provided was one gateway into Azure with unlimited bandwidth. Initially started with like 1 gig, then 10 gig and 100 gig, and it just keeps on getting better and better. Now, once this came in, this stabilized the landscape of connectivity for a very long time, and for around 4 to 5 years, till large-scale enterprise migrations started coming in, ExpressRoute circuit was the go-to tool. And even in today's state, that's the best network connectivity provider if you want to get into Azure. So the fastest way and the secure way is ExpressRoute circuit, and then its site-to-site VPN comes second. It's generally a cost comparison between these two when a solution is proposed. Now, once this was done, people thought, yeah, we're good, everything is going to work fine. And that was in 2017 and that kind of era, or that like 3 years ago. So what people expected was to have a hub and spoke network with all the connectivity going central via the ExpressRoute circuit. So essentially, as you can see on the slide over here, you have got your on-premise on the left-hand side, and then you've got your providers in the middle, and then you connect to Microsoft Azure and all the other capabilities using your ExpressRoute circuit. But you had a provider network in the middle, which is basically brokering all the on-premise networks into one location and then moving it forward. Now that was the limitation of an ExpressRoute circuit, that you can have basically one pipe to one place. And unfortunately, life doesn't work that way. It's all scattered. So everything wants to talk to everything, and it's basically a mesh topology. Now, in that scenario, the solution that was needed was more or less, so for a very long time, what the kinds of solutions that we were providing, we were saying that you have an SD-WAN on-premise, which collates everything, or you use a provider network. If you're going to use ExpressRoute circuit, create an edge of your on-premise where all of your on-premise routing is hosted, and then you basically move it across to Azure. And in comes Azure Virtual WAN. What it allows you to do is kind of create a centralized network again on Azure. So if you don't have an SD-WAN, if you don't have a network edge as such, where from on-premise perspective where you've got all the routing done, then you can have an Azure Virtual WAN, which allows you to create an ExpressRoute circuit, a site-to-site VPN, a point-to-site network to the same network capability in the same region using a bespoke technology. And that's why Virtual WAN came into picture, and it's become one of the most popular solution of late. In the past 6 months, I've seen most of the customers bowing down and going for Virtual WAN, either directly or at being looking at it as a solution for future. But that's where Virtual WAN came in. Marty, has there been any questions so far?
No, so far so good. It's just the general ones. I'll let you know.
Yeah, great, cool. So let's get into the overview of Virtual WAN. So what is Virtual WAN? So basically what Virtual WAN provides you is to have a managed hub and spoke architecture with automated routing and branch connectivity. What this means is that in most of the cases we had to set up UTRs and we had to set up intricate routing mechanisms when we went for hub and spoke topologies in the past. What Virtual WAN tries to solve is to have this in an automated way. Azure regions serve as virtual hubs. So you have got one virtual WAN per region and they can talk to each other, as you can see over here in this picture at the top on the right hand side. It has got a global scale and it allows 20 Gbps transfer. So obviously the transit rate is faster. It also says that if you have got two regions, you've got 20 to 20, 40 gigs. So it's double the benefit, but we'll hold our breath and see how much it performs. So I don't see it performing that well at this point of time. But when additional regions are connected, that the routing is implicit. So when I have got two regions, the connectivity between them just is implicit. I don't have to create any specific connections. I don't have to set up any specific routing. So those are the last 2 points where it says transit routing is branch to branch, from branch to VNet. All those routing is implicit. So as long as you connect your branches to a virtual WAN hub, they'll start communicating with each other. You don't have to set up any other specific networking component as such. What are the components of a virtual WAN? So you have got a virtual WAN resource which overlays, which is actually the regional resource. Then within a virtual WAN resource, you'll have your you got your virtual WAN hub. Inside that, you've got your sites, and then you've got hub to hub VNet connections. So essentially, if you look, sorry, my bad.
So we do have a first question, and Tim Taylor is asking, is the hub-to-hub data encrypted or only routed via Microsoft private connections?
So hub-to-hub data is not encrypted. We're going to discuss that as a part of the salient points. So anything that's on the Microsoft backbone is not encrypted, and hub-to-hub is going via that route.
Okay, thank you.
Great. All right. So, okay. So we get into the benefits, but before that, let's just see one implementation. I think most of you might have done these implementations, but let's just see.
Dhawal, maybe you can zoom in a little bit for the higher font.
Okay. Sorry, let me just bring it on the side. Is it better?
I believe so. Thank you.
Yep. So this is basically an Azure Virtual WAN. It's set up in West US, and it's got a live VPN site, which should not be active because I'm not connected to anything, but it's provisioned. Once I set up the link properly, it will start connecting. So right now it's saying unknown. So it's trying to connect to something. What it allows you to do is, as you can see, you can actually create VPN sites. So I've created one VPN site. You can connect ExpressRoute circuits. You can have point-to-site connections, and I've also connected a virtual network over here. I'm just waiting for it to come up. Anyways, it'll just show you one virtual network which is connected. So it'll show that you're connected to this one virtual network. It's very easy. As soon as I connect another virtual network and I say routing propagation to yes, they'll start talking to each other between the regions. Now, what you can see over here is that it takes an IP range, but it's bespoke, so you don't see a virtual network on which your actual virtual WAN hub is created. What you see is more or less a UI-based interface through which you can communicate with it. It's got REST API, PowerShell references by which you can actually set up these things. It's all a little new, so you will see things changing very quickly. So for instance, even if you look at some labs online, or you look at the Microsoft reference documents, you might see the actual UI slightly different. Don't be worried, it's a new thing, so it just keeps changing. Now, looking at Azure, so I just wanted to show you the components of Azure Virtual WAN. So that was just a brief look of how it looks like. Now, what are the benefits? First of all, for global routing, there's less complexity. So what happens if I have got a global network? What happens? What happens if I'm a big enterprise? I've got an entity in Australia, South America, US, and Europe. Now, as soon as they create virtual WAN hubs in each of these regions, they'll start communicating with each other using Microsoft backbone. So I'm getting the Microsoft Transit network. So the data never leaves Microsoft network, so it's secure in that way. And plus, it'll give you the speed of the networks that Microsoft works with. So so network latency would be reduced. It reduces your network performance. It improves your network performance because it basically reduces your hops as well. So if you have, for instance, if you are connecting between two regions using a provider, or if it's going via on-premise networks, in general cases, what happens is your UK would communicate with, say, for instance, your Latin America region via your company's backbone or your company's enterprise network. So it will go via from one IP from one IPS to another, one ISP to another, and it will keep hopping. And those hops would actually introduce network latency. So that is a performance benefit. There's an expanding set of partners. So what it is that all the SD-WAN providers are now basically integrating over here. So you're getting you're going to get best of both worlds, more or less. Like for instance, a deployment topology that a lot of people who did not have an SD-WAN capability used was to have Meraki or such devices in their networks. Now, all those things are integrated. So you've got SD-WAN providers integrated into your integrated as a partner with your Azure Virtual WAN. So you get that topology integrated with each other. I'm sorry, there's a parrot at my place who is really annoyed at me, I guess. So there's some background from him. Pardon me for that. It also simplifies your network management and network security. So you don't have to set up your peerings, you don't have to set up your UDRs, and your regional hub connectivity and everything works seamlessly without any issues. Those are the benefits, and that's what makes it very lucrative. Now, the primary use case was to have a kind of essentially have an SD-WAN kind of capability in Azure. So that it has provided, but now it's bettering it So as we get in the next section, it basically highlights that. So one of the basic question that has always been around any kind of networking in Azure has been its perimeter security. On that note, actually, before delving deeper into its details, has there been any question? I'll just quickly check the teams. I think
no, we don't have. No, we don't have any more questions, but guys, feel free. I already had a few questions, so seems everything working fine.
Yeah, fabulous. So yeah, so I basically collected a few reference architecture that Microsoft provides for networking. So this is a DMZ architecture. So anytime you go for perimeter security, what Microsoft recommends is to have a firewall in between so that any connectivity in and out of your network that goes via firewall. So you throttle your traffic, centralize it to a firewall and ensure that it moves via firewall. Anywhere where you got those things missing, you basically any traffic coming in from outside comes via a load balancer with at least a load balancer with Azure WAF or web application firewall enabled. If you don't have that, or if you don't have a firewall in front of your internet facing applications, you again are at potential risk. This is the Microsoft CAF or Microsoft CAF architecture, reference architecture that they provide for DMZ hubs. Again, they focus on the essential security around your perimeter. Now, what we've discussed about Azure Virtual WAN so far doesn't include any of these perimeter security. So traffic is just coming into Azure Virtual WAN and it's going out. Now, what do we do? What kind of topologies are there that Microsoft provides or are supported at this point of time from Azure Virtual WAN perspective that provide this kind of capability? The first one, and that is your indirect spoke. So when Virtual WAN came in, as Virtual WAN overall is kind of a bespoke piece of network, you can't deploy a firewall in it. So what it allowed you to do is to set up a separate hub for your NVA and allow for something which was called as indirect routing. So you basically had to go away with the benefits of your virtual WAN hub of not setting up the routing, but set up routing for your indirect spoke. Now, what this means is that you got your hub where all the traffic is coming in, but hub has got a route which says any traffic that wants to go out of this goes to NVA. And then the firewall decides whether that traffic is allowed or not. Any traffic from your spokes which wants to traverse the hub has to go back to the NVA. And then NVA decides whether it's allowed to traverse further or not. Now, this kind of topology was, first of all, complicated because you see you have to do peering at all the levels. So for instance, all of your spokes are peered to your virtual WAN hub as well as are peered to your NVA or your Azure firewall or Cisco firewall or your Barracuda or anything that you're using. For that matter of fact, anything grayed out is something that's on premise, so how it connects in is separate. Now, this was the initial topology, and which is called more or less as the indirect spoke. And there are a few issues with this. So Microsoft came up with a new topology, which again has got its flaws, but it's called a secure virtual WAN hub. As the name suggests, it provides security on top of your virtual WAN. So what it allows you to do is you've got your virtual WAN, and then you have it overlays your virtual WAN VNet with a firewall, and it allows you to manage this firewall using Azure Firewall Manager. So the only piece over here that was preview was Azure Firewall Manager, and that's why this was kind of a dicey solution, because you don't basically go ahead and sell a preview feature, a solution with preview feature for the customer. What apart from Azure Firewall, there are other integrations in the US region with Zscaler and iBoss, as this picture suggests. So you can have a secure partner in the shape of Zscaler and iBoss, which actually goes ahead and deploys within your secure hub and provides the same level of security. And then you've got your traversal stuff. Now, there was an issue with this particular mechanism that is prevalent, and it's still something that's not yet sorted. So what happens is when you look at, so when we get into the global networks, let me just skip the live demo slide and show you a global network. So what happens is Azure Virtual WAN basically allows you to talk between two hubs, and then if you've got hub-to-hub connection that's set up by default, if you've got two virtual WAN hubs in two regions, for instance, this is in UK South, this is in UK West, VNet from here, the traffic will go to the hub-to-hub connection and traverse this and go back over this network without any issues, and that connectivity works perfectly fine. Unfortunately, when you have a similar network in shape of a firewall manager, what actually happens is the traffic from this VNet goes to secure VWAN hub. Firewall has a policy that it allows the traffic out to this particular network. It goes back, but while going over here, it basically leaves this firewall because it's a direct transit. So it just goes directly through your hub and into the VNet. Now, when the response comes back from this VNet, it goes through the firewall because that's how the routing is set up. Now, when the response goes out of this and goes to the firewall, it says, I didn't see the traffic coming in, and it stuffs the traffic. That's kind of an asynchronous kind of routing which is happening right now, and because of which this communication is not working. So secure WAN hubs work perfectly fine if they are solo deployments. If it's a solo deployment, it works as required in one region, but as soon as you go for the global regional outreach, it doesn't work. So if you are going for a deployment with a customer, then you might have to compare which solution works fine. Then I would say if you're going for a global network, go for the indirect spoke topology with the layout that you would go to Azure firewall managed a global outreach once it's available and once it's working fine. Now, this is something that was this is a continuously changing landscape. So by end of September, I believe that this was to be sorted, but we're not yet at the end of September. So just throwing a caution to the wind and ensuring that you guys are aware of these concepts. Mari, any questions so far? If not, I'll get into the live demo of this.
Yeah, let's go with the demo.
Great. So I have basically created a secure WAN hub. So as you can see, it has created a firewall test. And if I go into the virtual WAN, and if I look for firewall here, hub. So
we do have another question from Jozo, and are there any workarounds for hub-to-hub asymmetric routing issue?
Not so far, Jozo.
Thank you.
Not so far. So that's something that we've been waiting for, and that's why at a higher level we are proposing the solution with a pinch of salt. So what it allows you, like for instance, you've got this is very basic implementation of a secure WAN hub, but as you can see, there is a firewall over here, and with Firewall Manager, you've got firewall policies. You can actually go ahead and create rules. Currently, there is only one rule created. It says default application rule, and it allows you to basically go ahead and outside of your networks and connect to MSFT resources. So that's an application rules. If you log into a virtual machine, and if you basically go ahead and let me just do that. And then you can actually just reach other. You can't reach any other sites. You can just reach Azure, so any Microsoft sites. Let me just go back to the overview of the hub. So it's not connected with anything, but it's secured using an Azure firewall. It should have two virtual connections. So you can see it's got a virtual network connection to spoke 0, and it's got a jump server and a workload server on which your workload is hosted. As you can see, you can actually interact. Yeah, this is the advantage of Azure Firewall Manager, that you can actually work with your policies as a separate template. So far with Azure Firewall, setting up a rule or any configuration in an Azure, and this is not related to Azure Virtual WAN as such, but so far with Azure Firewall, if you wanted to create a new rule set, you basically had to interact with the firewall as an object. But Azure Firewall policy using Firewall Manager is a separate object altogether. So you can create one policy which applies to multiple networks together, or multiple, basically controls multiple networking points together. So an example is if you've got two firewalls, you can apply same policies to two firewalls. There is a route that we have created, which basically allows you to connect from Jumpbox, and that's your actual firewall, which basically has got an internal IP, and we got a firewall manager. Sorry, firewall manager comes from your virtual WAN. So you can actually go into your hubs and select your hub, and that's where your firewall is connected successfully. You can actually view all your metrics in Azure Monitor. So anything that's going out in and out can be kind of measured directly. So you don't have to kind of put specific metrics data into Log Analytics workspace. You get all the details over here. So you can set up alerting directly. You don't have to set up separate diagnostics. One thing that I did not mention over here was point-to-site gateways. So apart from your ExpressRoute circuits and your site-to-site VPNs, what Azure Virtual WAN also provides you is the capability to basically go ahead and have a point-to-site connection. So what is a point-to-site connection is that I'll give you an example of a virtual WAN implementation that we did. So when COVID struck, there was one of our organizations which was struggling pretty bad, and it did not have any capabilities for remote working, absolutely. So the option was to set up an RDS farm or a huge infrastructure within their on-premise data center, and then allow people to connect through Citrix or these Citrix or RDS systems into this. Option 2 was to use Azure Virtual WAN as a broker. So what we did is we created an Azure Virtual WAN, connected all of their site offices, which were around 18 odd site offices, to that Azure Virtual WAN instance in a particular region, and then we had point-to-site connections to that Azure Virtual WAN. So traffic and these point-to-sites were working from the laptops that the people were using. So there was also a huge piece of activity that was created where WVDs or Windows Virtual Desktops, which is another feature of Azure that were being developed. So which basically allows you to have remote capabilities of your desktop services using Azure capabilities. So when these WVDs were being created, one of the packages that was being installed along with the security features was this point-to-site VPN configuration. So using point-to-site VPN configurations, all the laptops so configured or all the WVDs so configured were basically been able to reach back into the on-premise networks directly in a secure manner. So this way, this entire thing, around 800 laptops were rolled out over a weekend, and within 2 weeks, their entire workforce was able to work from home, which is one of the major use cases for them. So that's one of the use case of Azure Virtual WAN. Yeah, let's get into just go back, and so that was the secure virtual WAN demo. Eventually, we basically talk about the global virtual WAN network. Now, most of this network is something that is very useful, but currently with perimeter security deployments is a little bit cumbersome to deploy. So as I basically pointed out earlier, there is this issue with secure virtual WAN hub, and if you go for indirect spoke again, you end up with a very complicated networking topology that you would like to avoid rather than might want to avoid if there is a easier way to deploy these solutions. This is basically the Azure firewall based third-party integration-based networking topology. As you can see, you've got point-to-site coming in, you've got branches coming in, you've got Azure firewall basically governing the traffic between the regions. You've got two regions talking to each other. So for instance, VNet over here can talk to this branch directly via this route. Now, all of these governance is basically being done using a secure WAN hub in this diagram. But as we said, that it's got an issue. All right. So that's, I think. Yep. So we basically move into some interesting facets of secure WAN and Azure Virtual WAN as such. Any questions so far? Marty, any further questions? I don't see them on the Teams, so.
No, it's all good. It seems like everything is nice and clear, so.
Yeah, it's basically very simplistic concept. So one of my friends said that it basically is SD-WAN on Azure, and it is what, if you know how SD-WAN works, it's pretty much that on Azure.
Yes, I agree. It's very basic concept till you start implementing it.
Yeah, it's the issues when you start implementing it. So for instance, if you want to use BGP routing with it, it's advised to use BGP routing with it. But if you start using BGP routes, and if you're connected to two separate regions, and this is what I want to talk about in the salient points, because these are more or less implementational issues that you might actually face when you start using this. So for instance, let me go back to the previous slide. And so if you got your HQ branch and you've got your normal branch communicating to, say, for instance, this virtual WAN hub, and if you're trying to expose BGP over both of these routes, in most of the cases, the ASN numbers and the edge routers are going to be the same. They just want an active passive. They might actually want an active passive topology of network between these two offices, or it might be a live DR kind of scenario or a live DR scenario. So they might actually want to do weight routing, which is not currently possible. So what I mean by weight routing is it's also called cost-based routing. So what happens is if you've got two regions, for instance, HQ, so like UK South and UK West, and UK South is your primary region, and you want all the communications from UK South to be prioritized over UK West. So what some of the providers in the most of the providers that are there for on-premise networking topologies or networking SD-WAN capabilities, those kinds of devices, they have got this cost-based routing option where you can associate a cost to the traffic coming out of UK West branch. So you can say that it's +10 whatever the cost of this traffic is. So whenever traffic reaches your central hub, it will actually prioritize this traffic, and this traffic is not prioritized. So that kind of communication isn't possible right now with Azure Virtual WAN. Now, if you have got to, if you are peering via BGP and then you are providing the same ASIN numbers to both the links, your WAN gets confused as to where to send traffic, because your edge router's BGP IP address range and its ASN is same. So you've got two links which basically mean the same to Azure Virtual WAN, and it gets confused. And just imagine that we have had situation where they had live NDR regions, so UK South in Azure and UK West in Azure was there. UK South was primary, UK West was their DR. So they wanted connection from all of their branches to both of them. So there were two connections here and two connections there, and these two hubs were connected. So the traffic had 4 possible routes to go to, and it just got confused. So then we had to basically go away with BGP routing, and we had to go with name routing and use specific IP address ranges, so that the virtual WAN is aware where to send traffic for what IP ranges, rather than using BGP, in which it should deduce what traffic it should allow. Now within Azure network, traffic works perfectly fine. But when it goes to on-premise networking, it becomes slightly complicated, and hence you get those implementational issues.
So that's interesting. I think that's very useful and interesting for the people who are planning to implement like this, right? But we do have another question from Jozo, and asking. So you probably, this one we can qualify as a blocker, right? Or not available at the moment from a Microsoft perspective. But Jose is asking, are there any limitations on using site-to-site VPN routing options? BGP, policy-based, dynamic, anything else, and the implications on route advertising between the hubs?
Okay, let me just see.
Are there any limitations on site-to-site VPN routing options?
Okay, policy-based, dynamic, BGP, and the implication. Yeah, that's what I was talking about right now. So if you go for policy-based implementation, it will work perfectly fine. If you're going for BGP-based implementation, this is the kind of mess that you end up with. So now between the hub, if between the hubs, the communication between these hubs, Azure is very clear, and that communication works perfectly fine, as in it internally uses BGP. So anytime you have got site-to-site connection between two VNets, or if you got peering between two VNets, or if you got global VNet peering, it works perfectly fine, because it reduces your BGPs and ASNs perfectly okay. It is when you start communicating with these things with on-premise kind of communication, then you have to go for policy-based. That's my advice.
Okay. We do have another question from Rich. Mm-hmm. Dhawal, are you able to see the questions? Which are
yes. Yeah.
So let me. Okay, so let me just read it, because I'm not sure how the recording is working. So just that it would be available for the people who are going to look in a YouTube later on. So Rich is asking that they do have traditional hub and spoke layout within the Azure, and with network virtual appliances in hub routing between the spokes, and as well as on premises network traffic via ExpressRoute gateways. And do you have any guidance on transitioning across to have Azure Virtual WAN architecture? And if you recommend, based on your experience, to make this transition, or just wait till some enablements are going to happen in the near future, possibly in the near future.
Okay, I just had one question on this question, and that was more or less, let me just explain. So if you have a ExpressRoute circuit and a regional topology, then you can actually have Azure Virtual WAN hub, and you can terminate your ExpressRoute circuit at the virtual WAN virtual WAN hub instead of a virtual network, the way it would be right now, and the transition would be seamless, and then you can have multiple multiple Azure virtual networks connected to that virtual WAN hub in that region, communicating via that express route circuit. It will allow you to have a capability to have another site-to-site VPN within the same region to a separate site apart from the express route circuit that you already have, and your NVA can work as an indirect spoke. The way, let me just go back into my slides a little bit. So we had an indirect spoke topology that would work perfectly fine over here. So your NVA and then your virtual WAN hub, and instead of VPN gateway, you'll have your express route circuit coming in over here, and you've got your separate VNets. So you already have your VNets connected to your NVA subnet, NVA virtual network at this point of time, and maybe your express route would be terminating over here. You can actually start. By the way, Marty, you can see the arrow, right? The pointer that I'm moving. Yeah, perfect. Yeah, or else it wouldn't mix. Yep. So, and then you've got your virtual WAN hub. You can set up the separate network. You can have your express route circuit terminating over here, and then the communication. You can just connect the virtual networks and then set up the policies, routing policies as you require. If you want to go for Azure Virtual WAN, that would be the kind of an advantage or the process to go ahead with, and that would allow you to have more regional connectivity. Now, but if you're talking about multi-regional implementation, then a hub-to-hub communication again becomes an issue, and that is where most of the issues are there in today's state. So that's why I would recommend testing your policy-based communication first of all with a test environment, and if it is working perfectly fine, we've seen it work perfectly fine for multiple customers. It's not as if that it doesn't work. It is just that it's slightly cumbersome, and you would have to use policy-based instead of BGP. In fact, for one of our customers, even BGP worked. Once we had just single connections and two separate ASNs and separate BGP edges. So we had two different. So the customer operated in, I think they had one data center in Cardiff and one data center in somewhere in Germany, and I think it was closer to Berlin. And those both two data centers had two different edges with two different devices, which exposed separate ASN numbers and separate BGP endpoints, and they were connecting to live to two different regions, and it worked perfectly fine. So it depends upon topology to topology. I just am more of a critique, so I might actually dish out the negatives first before I say the positives. The advantage of Azure Virtual WANs are amazing. So as I said, that it's already integrating with multiple partners. It's already integrated with multiple SD-WAN partners. So maybe using a Meraki device, or maybe using some other partner to deliver your solution might actually reduce your complexities and help your deployments better. So I would say it's a changing landscape. So depending upon your requirements, we can identify more things. And in fact, yours seems to be a really interesting issue. I'm not sure you can communicate with me. Marty, is there a way that we can stay in touch after this? As in I can stay in touch with them?
Yeah, definitely. So Rich or anyone else, feel free to post the questions or in a comment section in this particular meetup event, and we'll be able to come back to you or elaborate more on the questions.
Yeah, fabulous. So yeah, let me just go back to the presentation and talk about the interesting points. So you've covered some of the salient points, but let's just read these. There's a lot of verbs over here, but essentially it goes back to whatever I've said, that devices connected to Azure Virtual WAN have built-in automation connection. So it's got connectivity partners associated with it. So it's got local connectivity partners, direct connections. So for instance, it's not as complex as, so for instance, creating a site on an Azure Virtual WAN is easier as compared to creating a site-to-site VPN connections. Although essentially it's under the hood, it's the same concept, but you would find that integrate the UI as well as the ARM are much better, because they've considered the recommendations that have come in the past. VWAN ER VPN gateway replaces needs to run conventional VNet ER VPN gateway. So you basically this is again a very nice UI and a very nice deployment mechanism through which you can actually get rid of having multiple wait times for creating your VWAN ERs. And so whenever you basically create a virtual network and you connect using a VPN gateway or a ER gateway, those things are more or less complicated, and the topology and the way it is being deployed over here is just the sharing of keys and everything is much easier. A point to note is when you use ExpressRoute circuit, you would have to use premium SKU because your under the hood VN basically uses ER global reach. So ER global reach is the connectivity mechanism through which it connects different regions. So the global connectivity is using ER global region, hence it requires you to use premium SKU. There was one question earlier, I guess, from Rich, which was about traffic that passes over Azure backbone. That is not encrypted. So anything that's between hub to hub is not encrypted. Anything that is from hub going out onto on-premise or going out via on-premise depends upon your IPsec tunnels, and it's encrypted that way. Anything going out to internet depends upon your firewall configurations. So again, it's a cost-effective solution of running your landscape. As I said, that as it's new, it's got that bandwidth and capabilities imbibed into it, so that it becomes a lucrative options. It's always the case with any new Microsoft offering. It starts at a cheaper rate, and then once it becomes a hot cake in the market, then slowly the cost goes up. So right now it's the right time to invest in it so that you get the best cost and cost effective. We have to understand that some features are still in preview. As I said, hub-to-hub connectivity is in preview. It's got issues. Azure Firewall Manager, some features of Azure Firewall Manager like the DNS piece of it is still under preview. So it's a preview features. If you go for a secure WAN hub, you have to be clear with your customers that, yeah, it's a preview feature. It's got an issue right now, so it's got an issue log as well. So it's got few issues. As I said, inter-hub communication not working with secure WAN hub. It's a known issue, and you can find it under new known issue link. Now I had times for Q&A. Any other questions beyond whatever we have discussed so far?
Not as yet, but I would like to encourage guys to ask any questions. Let's wait for a few minutes.
Yeah. Let me explain a few, not explain, let me just give a few examples of virtual WAN implementation that we have seen. So I've seen one implementation where virtual WAN was integrated with Zscaler as a requirement. So it was a US-based customer where virtual WAN hub was used, and all the outbound traffic, because they already had a Zscaler license, so all the outbound traffic was hooked in via Zscaler. So, but it was again a regional deployment, so it worked perfectly fine, and all the different regions within US were connected. So when I say region, I mean one global region rather than say one Azure region rather than a global region. So all the other connections were working perfectly fine. I've seen one implementation where one virtual WAN hub was created in UK region, and that was connected to almost 7 or 8 regions across the world, including Australia, Malaysia, South Africa, and that implementation is also working fine. The reason for having one hub only and not having multiple hubs in each region was the global transit issue that is currently pertinent.
Okay, we do have another question from Joso, and the question is there an option or in a backlog to overlap the regional hub address ranges, like source netting, the outbound traffic between hubs?
No. The IP ranges have to be exclusive at this point of time. This is something that that's a good question, Jose. And to be honest, I have not asked. I've been kind of communicating with the Microsoft guys implementing this for last 3 to 4 months. This is not a question or it's not a requirement that I've looked at, but right now that's not a capability. So I might have to get back to it and check with guys that maybe it sits on Microsoft's backlog, but I'm not aware if it is.
Okay, thank you, Dhawal. And if you don't have any other questions, I want to thank you, Dhawal. And for the participants, I would like to remind once again, please, if you can spare a few pounds, jump on the link and buy Dhawal a coffee. That would be nice, that he can drink, relax, and hopefully present in our meetup groups sometime in the future. And Dhawal, just before, okay, we do have another question. Again from Jozo, and is private link supported in this virtual WAN designs?
Private link as in anything that's okay. Let me just see. Let me just think if it's supported. Essentially, it should be supported. I've not seen its implementation. Again, private link generally is a link to a PaaS service to your virtual networks, and it gives you an internal IP range. So it is a supported use case for virtual networking. So I believe it should be. I've not done an implementation, but it's not an. I don't think so. It would be. It would not. It would be an unsupported scenario. I'm pretty sure that it is supported.
But we don't know the roadmap or the timelines for that, right?
Because it's not integrated with Azure Virtual WAN, right? So it's not a connectivity that where you basically, for instance, you don't connect a private link to ExpressRoute circuit or anything like that. You connect a private link to a virtual network, and as long as you're connected to a virtual network, you'll get an internal IP address within your IP schema. And that would be routable, and that routing should work via your virtual WAN hub without any issues. This is my understanding of it. Maybe it might be an unsupported scenario, but I'm pretty sure that it would not be that case. Okay. It's an indirect link to the virtual WAN implementation. It's a networking piece, but it's not connected directly.
Okay, and another question we do have from Richard, and how do you like your coffee?
I like normal coffees. In fact, one of my when I used to get client sites, one of my favorite was cold brew. So the way it is made is that they keep the coffee in the refrigerator overnight, drenched in water, and whatever is that water, they basically sell it off the next day, and it's very high on caffeine, and it keeps you going throughout the day without any issues. So I just love it.
Okay, that's a good advice, probably for someone who is going to implement virtual WAN in the future, because it seems that with the limitations and the blockers, you might need it. So, Dhawal, thank you very much. Thank you all the participants for all the questions. We hope so that recording will be available soon. We'll share the link in the YouTube channel. And thank you very much for participating. We'll meet next week on Tuesday. And one of our members is going to present about the AKS and deployments to a different cloud, to the different clouds. So thank you very much, everyone. Dhawal, thanks a lot, and speak soon.
Yep, thank you so much. Thank you. It was fun. Albeit it would have been good if I could have seen a few people. Hopefully next time when we are there, we can meet and talk with people in person. Yeah. I would love to meet Joseph.
I'm pretty sure you will.
Cool. Thanks, Marty. Thanks, Daniel, for having me. Thank you.
Thank you.
Cheers, guys.